Um, hey guys, welcome. So while there will be a lot more videos on logarithms because I love logs, this video will be dedicated to introducing the product rule for logs. And the product rule is probably like the second most important thing after the definition of logs. So you really need to know this. And let's get a feel for this product rule by first writing log base 2 of 32. Now, we all know the log base 2 of 32 is equal to 5 because from the definition of logs discussion, we know that this is called the logarithmic form, and it's equivalent to the exponential form, which translates this to saying 2 to the 5 is equal to 32. Well, this is true, but because this and this are equivalent, if this is true, this must be true. Yeah? In fact, the way we solve for log base 2 of 32 is by translating in this form, right? Like, so we'd write log base 2 of 32 equals question mark, and then translate into the exponential form, which is 2 to the question mark is equal to 32, which should mean question mark is equal to 5, and that's how we solve logs when we're not using calculators, right? Okay, cool. All right. So we know log base 2 of 32 is 5. There's nothing new or fancy about that. What's new is this. What about if we curiously wrote log base 2 of 4 times 8? Surely this should also equal 5 because, well, it's still saying log base 2 of 32, right? And this here is called the argument, and this 2 is called the argument, right? So, like, yeah, what we plug into logs is the argument, right? Like, okay, as usual. Like, stuff we plug into functions is called the argument. Okay. Anyway, what we want to know is, like, if we can write 32 as a product of two numbers, how does it work? How can we write, like, log base 2 of, like, one of the numbers, 4, and then log base 2 of 8, and do stuff between them? And what is the stuff between them? Do we multiply them? Do we add them? Do we subtract them? Or do we divide them? It turns out that what we have to do is add them. Because check this out. What's log base 2 of 4? You're asking 2 to the question mark is equal to 4. That's 2. So log base 2 of 4 is 2. So we'd have 2 plus log base 2 of 8 is 3. So we'd have 2 plus 3. And that is surely 5. So it worked here, but does it mean that it works all the time? Yes, because we can even split it into three numbers, 32 that is. And so, like, we could write log base 2 of, like, how can we split it into three numbers? I don't know, boring, but like 4 times like 2 times 4. Then in this case, we'd have to write that this is equal to log base 2 of 4 plus log base 2 of 2 plus log base 2 of 4. Is this still true? Yes. This is 2. This is 1. And this is 2. And 2 plus 1 plus 2 is still equal to 5. And this is still log base 2 of 32. Yeah? Okay, cool. So yeah, this is good. And so this is basically the product rule. So let's state it formally. And we'd have to write the following, which is log base a, and it could be any base a, of the absolute value of x times y is equal to log base a of the absolute value of x plus log base a of the absolute value of y. So this is how the product rule works. But wait, when I stated it formally, I've written stuff that I have not written before, namely the absolute value there, the absolute value there, and the absolute value there. And it turns out that the absolute value is crucial. And one reason is because, like, you know, like, we don't know how to make sense of log base 2 of, like, negative 4, right? Because, like, if we write what is log base 2 of negative 4 and convert to the exponential form, we're asking 2 to the question mark is equal to negative 4. But wait, there is no exponent of 2 that will return a negative 4. And so this does not make sense. But if we go back and write log base 2 of absolute value of negative 4, so log base 2 of absolute value of negative 4, we know how to make sense of this because it's saying log base 2 of 4, which we know to be 2. Yeah? Okay, cool. So this is kind of like a cheap explanation for why the absolute value is necessary. But I'll explain why the absolute value is necessary in the context of the product rule. And here's how. And by the way, I should credit this explanation to a Russian friend of mine, David Yakubov, who at lunch one day explained to me why, in the context of the product rule, we need the absolute values around logs. And here's how he did it. So he said look at log base 2 of 32. Earlier, we broke it up into log base 2 of 4 plus log base 2 of 8. But we can write the log base 2 of 32 is equal to log base 2 of not just 4 times 8, but negative 4 times negative 8. Because just like 4 times 8, negative 4 times negative 8 is still positive 32. But then we'd be misled into thinking that we can write log base 2 of negative 4 plus log base 2 of negative 8. As I said, this doesn't make sense, and surely that doesn't make sense either. So the absolute values are important. Yeah? Cool. All right. Now, in a future video, I'm going to prove the product rule. In other words, I'm going to prove this statement. And it's actually very easy to prove it, and it's a fun proof. So look out for the video on that. And in addition to the product rule, there are two other important rules: the quotient rule and the power rule. So look for videos like this on the quotient rule and the power rule, and proofs of the quotient rule and the power rule, just like how I'm going to do a proof of the product rule. All right, I'm going to conclude with a logarithmic equation that we're going to solve here, right? Now, I'm going to also have many more videos on logarithmic equations, so this is just like to introduce the product rule. So yeah, this is kind of like a bonus at the end of, explaining what the product rule is. But yeah, let's suppose we're looking at a logarithmic equation that reads log base 2 of absolute value of x minus 1 plus log base 2 of absolute value of x plus 1 is equal to 3, right? Let's not use 2 or 1 on the right side for variety's sake. Okay, so how do we solve for x here is the question, right? Well, immediately we have to realize that this is in this form. In other words, it's like the product rule after it's been applied, right? So we need to go backwards. By the way, that backwards process is called condensing logs, and I'll have a video with many examples on condensing logs and like hard examples. And the process of going from here to here anticlimactically is called expanding logs. So you can go from here to here by expanding logs, and you can go from here to here backwards by condensing logs. So here, to solve for x, what we must do to start is condense the left-hand side. And that would look as follows. We write log base 2 of absolute value of x minus 1 times x plus 1, and we say this equals 3. Yeah? Cool. And then next we write log base 2 of absolute value of x squared minus 1 is equal to 3, right? Okay, cool. Now at this point, you can abandon the absolute values here and just write log base 2 of x squared minus 1. I'll explain shortly why. But let's first see how to finish from here, right? Well, look, this is in the logarithmic form. So to finish, let's convert to the equivalent exponential form to this. That'd be 2 to the third is equal to x squared minus 1. That is 8 is equal to x squared minus 1. And so 9 is equal to x squared, meaning x is equal to plus or minus 3, right? And notice both positive 3 and negative 3 work in here. You can plug them in and check. In both cases, you'd have to say log base 2 of 8 on the left-hand side, which is, in fact, 3. Log base 2 of 8 is 3, right? Okay, cool. Now, so before I sign off, why can I abandon the absolute value there? Because if we kept this form instead of this, then from here, what we would have said is 2 to the third is equal to absolute value of x squared minus 1. But based on our absolute value lessons, we know that we can split this into two equations, which is 2 to the third is equal to x squared minus 1, where this is identical to that, right? Or negative 2 to the third is equal to x squared minus 1. But this here is claiming that this could be negative 2 to the third. But we said it can't, right? Like, this whole thing cannot be equal to negative number because we be finding log base 2 of a negative number, and we know that that can't work. Yeah? Okay, cool. So this is it for the product rule. I think it's a good intro video. But otherwise, keep an eye out for all of the other videos that I said are to come. And last but not least, logs are really cool, and not just cool, but a favorite of contest math. So if you're a student who wants to participate in math competitions, then knowing your logs is very important. And naturally, a lot of cool, interesting contest math problems come up in the context of logs. So I'll do some contest problems involving logs. So keep an eye out for those videos also. Yeah? Okay, cool. Take care.